Alright, the topic for today is Pythagorean Theorem. And if you remember, that's when two or three sides of a right triangle are known, the third side can be found using the Pythagorean Theorem. The Pythagorean Theorem says the square of the hypotenuse is equal to the sum of the square of the legs. So something like this. Hypotenuse squared is equal to leg squared plus leg squared. You might be familiar with it going like this. A squared plus B squared equals C squared. Right. Where the hypotenuse, that's always the longest side, the side across from the 90. Right. And then these two are the legs. Right. And it doesn't matter, either one of these could be the A, so I'm just going to let this be my A, say that one be B, and my hypotenuse always is C. Alright, so let's look at an example just to kind of review. Alright, the X in this case, that's going to be across the hypotenuse, so that's going to be my C. This will be A and B. So we'd have 3 squared plus 7 squared is equal to X squared. Right, so if I go ahead and square this, is going to give 9 plus 49 is equal to X squared. 9 plus 49 would be 58 is equal to X squared. And in order to get down to X, I would have to take the square root of 58. So now I see 58 can simplify. Alright, so if I factor 58 and say I do 2, then that's going to be 2 times 29. 2 and 29 are both prime. So 58, the square root of 58 does not simplify. So this would be my answer. So we always want to make sure that it's in simplest form. Alright, we got another example to look at. This time the X is on one of the legs. So we would have 6 squared plus X squared is equal to 6 square root of 2 squared. Okay, so if we square this, this is going to give me 36 plus X squared is going to be equal to 6 square root of 2 times 6 square root of 2, which is going to be 36 times 2, which is going to equal 72. So let's see, bring this down, 36 plus X squared equals 72. So I'm going to subtract 36 from both sides, and I get X squared is equal to 36. So I have to take the square root of both sides, and that tells me that X is going to equal 6. Alright, next example, we want to find the length of a diagonal of a rectangle with the length of 8 and a width of 4. So for this, just to kind of help you visualize, I'm going to go ahead and draw a rectangle. Alright, remember this would be 90 degrees, so I'm going to go ahead and make my diagonal here. And so let's say the length is 8 and the width is 4. So this is what I'm looking for. So I would say 8 squared plus 4 squared is equal to X squared. 64 plus 16 is equal to X squared. If I add these two, that's going to give me 80. Then I need to take the square root. And again, I want to see if I can simplify this. I would factor this into 16 times 5. And 16 would be 4 and 4. So there's a pair. So this would equal to 4 square root of 5. Alright, next example. Find the length of the diagonal of a square with a perimeter of 24. So if I have a square and I want the diagonal. Well, if for a perimeter of 24, that means all the sides are the same. So I would take 24 divided by 4, and that tells me that each side is 6. So this would be 6 and 6 all the way around. So I'd have 6 squared plus 6 squared is equal to x squared. So that gives me 36 plus 36 equals x squared, which means 72 is equal to x squared. X would equal the square root of 72. Again, I want to factor this. That is going to be 36 times 2. And so there's my pair, so that means x is equal to 6 square root of 2 in simplest form. Alright, next example, I'm going to give you something that's a little more involved. It's an isosceles trapezoid. We want to find the distance x. Right, well, if this is 90 degrees, that means this is 90. So inside here I have a rectangle. So I know this distance has to be 10. Right, and I want to find out what this little piece right here is. Okay, so here, this is my hypotenuse. So I'm going to call this, just so I can call it something, I'm going to call it A. So I have A squared plus 8 squared is equal to 10 squared. Right, so A squared plus 64 equals 100. Subtract 64 from both sides. A squared is equal to 36. So that means A is equal to the square root of 36, which is 6. Alright, so here A is 6. And because it's an isosceles trapezoid, this is 8 and this is 10. This side over here is going to be 6. So x is going to equal to 6 plus 10 plus 6, which would come out to be 22. Alright, we're going to use now the Pythagorean Theorem along with some stuff that we've learned in the past. Recall that given three sides, a triangle can only be formed if the sum of the smaller two sides is greater than the third side. So in other words, A and B would represent my two legs, or my two smaller legs, and that would have to be greater than the third side. So real quick, looking at some examples, which of the following lengths could make a triangle? So if this is A, B, and this would be C, because that's the biggest side, is 4 plus 5. Is that greater than 6? Well, yes, 4 plus 5 would be 9, so that would be greater than 6, so this would make a triangle. If I looked over here, this would be my C. Is 4 plus 5 greater than 9? This one would not be true, it would be equal, so this would not make a triangle. Same idea with this, 4 plus 5. Is that greater than 10? No. So this would also not make a triangle. The only one that would make a triangle would be A. So we're going to take this idea with the Pythagorean theorem to come up with another idea. I recall that one way to classify triangles is by their angles. And a triangle can either be an acute triangle, obtuse triangle, or a right triangle. If a triangle can be formed, you can determine the type of a triangle formed by comparing the square of the longest side to the sum of the squares of the shortest sides, A and B. So in other words, it is a right triangle when C squared is equal to A squared plus B squared. Okay. If it's an acute triangle, that would mean that C squared has to be less than A squared plus B squared. An obtuse triangle would tell you that C squared has to be greater than A squared plus B squared. Right? So we would have to check if we can actually make a triangle. So we'd have to use this idea here along with this idea, which looks like the Pythagorean theorem, to determine Number one, if it can make a triangle, and then what type of triangle it would be, whether it's right, acute, or obtuse. Alright, so we got another example. Determine if a triangle can be formed, and if so, we got to figure out what it is. So if I have, this is my longest side, so that's going to be my C. Remember that we have to check, is 5 plus 4, is that greater than 12? Well, 5 plus 4 is 9, and it is not greater than 12, so this would not make a triangle. Alright, this example here, 8 is my longer side, so 6 plus 7, we want to check, is that greater than 8? Well, yes, 13 is greater than 8, so it does make a triangle, and now we have to figure out which one it would be. So I'm going to take my C, which is the 8, and I'm going to leave that as 8 squared, and then I want to compare that to a squared plus b squared. So we would say 6 squared plus 7 squared. Okay, this would be 64. This is going to be 36 plus 49. 36 and 49 is going to make an 85. So 64 would be less than 85. So c squared is less than a squared plus b squared. So then this would be an acute triangle. All right.